Okay. Hi, welcome to my next video on how to predict the compounds structures. So, this you would have studied in your chemical bonding chapter in class 11. So, there are various tips and tricks to study the structures of the compounds. I will teach you as many as possible. Hope you do not get confused between different methods. Okay. So, there are basically two methods by which you can find out. I mean, there are three methods, but I will teach you only two. There are two good methods by which you can predict the structures of any compounds. Okay. Now, let us see what are those two methods. The first one is you use a formula to find out the hybridization H. Hybridization H is given by half into total valence electron of the central atom. Total valence electron of the central atom plus number of monovalent atoms surrounding that central atom. Suppose if you have say PCl5, chlorine is monovalent. So, you will have 5 monovalent atoms and we will see the examples. Minus cations, the charge on the cation. Suppose if you have 1 plus you put 1 here, 2 plus you put 2 here and like that. 3 plus means you put 3 here. You subtract that and you add the anion. Suppose if it is 1 minus you will put 1, 2 minus means you put 2, 3 minus means 3 and so on. So, this will give you the hybridization of the particular central atom, and this hybridization, if it is going to be 2 then it will be sp, 3 means sp2, 4 means sp3, 5 means sp3d, 6 means sp3d2, 7 means sp3d3. And you know the shape is sp means linear with 180 degree, sp2 means trigonal planar with 120 degree. So, you will have 120 degree, sp3 is tetrahedral. So, you will have tetrahedral. So, the angle will be 109 degree, sp3d 5 will be, you will have trigonal bipyramidal like this. So, here the axial bond will be 90 degree, equatorial bond will be 120 degree. sp3d2 will be square bipyramidal like this. So, here you will have again the axial bond will be 90 degree and the equatorial bond also will be 90 degree. sp3d3 will be pentagonal bipyramidal. You will have pentagonal bipyramidal like this. So, pentagonal bipyramidal like this. So, here again the angle will be 90 degree in both the cases. Internal angle of the pentagon will be different. Okay. So, we are not concerned about all those things. So, with this background information we will try to predict the compounds, structures of various compounds. Okay. Now, let us take the example of PCl5. Now you should remember that phosphorus belongs to NPOS and B. NPOS and B, where An is Sb, antimony. I have given you how to remember the names, symbols, atomic numbers and electronic configuration of all the p block elements by using a short mnemonics in my another video. Please do watch that video and so that you will remember the atomic number of each element that you can find out here. So, now nitrogen, this phosphorus, you will have if you remember the valence electron of the first element, then you can know the valence that will be same for all the elements. For nitrogen it is 7, that is 2, 5. So, 5 is the valence electron, therefore, all the elements belonging to this group 15 will be having 5 electrons, 5 as the valence electron. Okay. So, now you will have the formula will be half into total valence electron of the central atom will be 5 plus number of monovalent atom. Chlorine is monovalent, it is 5. Since this is neutral, this is not an ion, so neutral, so there is no anion or cation, therefore, this will be 0, this will also be 0, that will be equal to 5. So, 5 means you will have sp3d as the hybridization, and the shape will be trigonal bipyramidal. Okay. So, in this there is one more corollary point. If you want to find out the number of lone pairs present in these compounds, if at all it is present, then the lone pair will be given by hybridization minus number of surrounding atoms. So, here you will have the hybridization is 5, number of surrounding atom is also 5, therefore there is no lone pairs in this compound. Therefore the structure of PCl5 is trigonal bipyramidal with the axial bond angle will be 90 degree, equatorial bond angle will be 120 degree. Incidentally, in this case, if you look at the structure closely, like this, chlorine, chlorine, chlorine and chlorine and chlorine. So each chlorine atom will have 3 lone pairs. Therefore there will be a lot of electronic repulsion between these two. So lone pair repulsion will be here. So here you will have lone pair repulsion, lone pair repulsion. Similarly here also you will have, here also you will have. So in order to avoid this lone pair repulsion, this chlorine atom will try to go up, little bit up. Therefore this chlorine will go up like this. Therefore the axial bond will be longer. Than the equatorial bond. So this is called as the equatorial bond. These 3 are called as equatorial bond. So equatorial bond PCl bond will be shorter, axial PCl bond will be longer due to electronic lone pair repulsion between these 2 electrons. So this you have to remember in the case of PCl5 molecule. Now let us take another example of say SF6, sulfur hexafluoride. So if you take sulfur hexafluoride again, you will have this. So here this is OSA-TAPO. So this mnemonic you have to remember. Again oxygen you know, now atomic number is 8, electronic configuration is 2, 6. Therefore all the elements will have 6 as the valence electron. So this is how you find out the number of valence electron of the compound. So 6 plus fluorine is a monovalent atom, therefore 6 monovalent is there. Since the compound is neutral, it is neither a cation nor an anion, therefore no cation, no anion. So you will have like this. So 6 plus 6, 12, again it will be 6. So 6 means sp3d2 square bipyramidal. You can also call this as octahedral or square bipyramidal. So the hybridization will be sp3d2 square bipyramidal or octahedral. Now the number of lone pairs will be hybridization minus surrounding atoms. So hybridization is 6, surrounding atom is also 6, it will be equal to 0. Therefore there is no lone pair present in this compound. So therefore the shape of this will be sulfur like this, F, and you will have F like this, and each fluorine will have 3 lone pairs. All the halogen atoms will have 3 lone pairs to each other, Since this is a small atom, here the repulsion will not be very much as compared to phosphorus and chlorine. Chlorine is a bigger atom, fluorine is a smaller atom like this. So this is how you find out the structure of the compound using this formula. Now let us take an example of an ion, say NH4 plus. Now nitrogen, so hybridization H is equal to half into number of valence electron of the nitrogen, we have already seen, it is 5, plus valence electron is 5, number of monovalent atom, hydrogen is monovalent, so you have 4 hydrogen, and then you have a cation is plus 1, therefore you have 1 cation which is to be subtracted, no anion, remember. So therefore this will be 5 plus 4, 9 minus 1, 8. So that will be half into 8 will be 4. Remember, there is a shortcut, tips and tricks. This value, inside this value will be mostly an even number divisible by 2. If it is not divisible by 2, then you have to double check whether you have done this calculation correctly or not. In 95 to 98% of the compounds, you will always get an even number. Okay, so you have to ensure that. That is just only a tips to remember that. So 4 means what? sp3. sp3 is tetrahedral. So nitrogen 1, 2, 3, 4. So you have 4 hydrogen like this with a positive charge on the nitrogen, and therefore the angle will be 109 degree, 24 minutes if you want. Okay. So this is how you find out the shape of a molecule or ion using this. Now we will see one more anion. Say for example, CO3 2 minus, CO3 2 minus, or you can also find out for SO4 2 minus. So again you will see hydrogen is equal to half into osate apo, sulfur will have 6 valence electron, 6 plus oxygen is not monovalent, oxygen is not monovalent, therefore this will be 0, this will be 0, okay, you have to be very careful with this. And cation is 0, anion is 2, you have 2 minus, so you will have 2. So you will have again half into 6 plus 2 8 will be equal to 4. So 4 will be sp3. So sp3 will yes 1 2 3 4, 1 2 3 4. So you will have 2 minus, so each oxygen will have 2 oxygen will have minus charge, other 2 oxygen will have 2 lone pairs. Sulfur valence electron is 6, therefore you will have 6 bonds. Here you have only 4 bonds, so you have 5th bond and 6th bond. So this will be the shape and structure of sulfate ion with a tetrahedral structure. So this is how you predict the structures of various compounds. We will see some more compounds in my next video with a JEE and NEET level questions. Okay. Thank you for watching.